Hello, grade nines. This again is topic 6.3. This one is titled Other Forms of Equations for Linear Relations. So again, we're still graphing linear relations. This time the equations are just going to be in a little bit different form than what you're used to seeing, but it's not too tough for you, I don't think. So if I look at this first one, this equation form, they have ax plus by equals c. So what I've got is, instead of my standard, what I've seen before is something like y equals 2x plus 4, and we've graphed that linear relation. Many times we've talked about their created equations based on patterns, and we always write them in this form as well. And that's usually what we see. This is the equation of a line, and this is kind of the form that we usually write it in. But sometimes they'll give us equations in a different form. For example, this one here, I've got three x minus 2y equals 6. So the equation is not in a standard form that we normally see. This is still a linear relation. And what we do is basically the same way we plotted or graphed equations last time. We substitute values of x into the equation, generate values of y, and then we plot the points. So the process is the same. The equations maybe just a little bit more difficult and involves a little bit more algebra. So if I take this equation and I have 3x minus 2y equals 6, and it does tell me, it wants me to make a table of values if my x is negative 4, if my x is 0, and if my x is positive 4. So in the first one, I'm going to take negative 4, put it in for x, and solve for y algebraically. So it'll look like this. So I'm going to take 3 times negative 4, it tells me what that x value is, minus 2y equals 6. So this is what I've got. Now I'm going to multiply these two together, so that will give me negative 12. I still have minus 2y equals 6. So now I have to use some algebra skills to solve for y. And again, just like we did in the algebra unit, I want to isolate the variable. I do that through opposite operations. What I do to one side, I have to do to the other side. So I've got a minus 12 here, a negative 12. To move this 12 to this side, I do opposite operations. So I'm going to add 12. What I do to one side, I do to the other. So this is a two-step algebraic equation. Those are no longer there. I have negative 2y. Again, don't forget the sign attaches to that. And 6 and 12 is 18. Now I divide both sides by negative 2, and I get a y value of negative 9. So when I make my table of values, when x is negative 4, my y value is negative 9. So let's do the same thing for the 0 and the 4, and then we'll write the table of values after. So in this one here, same equation. I've got 3x minus 2y equals 6. And in this case, we're going to take x as 0. So I'm going to go 3 times 0 minus 2y equals 6. 3 times 0 is 0. So I have 0 minus 2y equals 6. Get rid of that thing there. There we go. Clean this up a little bit. So 0 minus 2y equals 6, or I can just say, if you want, negative 2y equals 6, if the 0 doesn't do anything. So now I want to solve for y, divide both sides by negative 2, and I end up with y is equal to negative 3. So when x is 0, y is negative 3. Another piece for my table of values. I'll try and fit this last one in here maybe. Original equation, 3x minus 2y equals 6. So here's my 3x minus 2y equals 6. This time I'm saying x is positive 4. So I put in 4 for x. And 3 times 4 is 12. minus 2y equals 6. Just going to slide this up so I have some room. And now I want to isolate the negative 2y here. So again, opposite operations. I subtract 12 from both sides. And I'm left with negative 2y. 6 minus 12 is negative 6. Divide both sides by negative 2. And I end up with y is equal to 2. That looks like positive 3 to me. So now I have a table of values. And what I can do is I'll put that right over here. Let's put our table of values here. So let's go here and here. So here's my table of values. There's my x, there's my y. Here's my x values. I had negative 4, 0, and positive 4. And when I put negative 4 into this equation, I generated a y value of negative 9. When I put 0 into this equation, I generated a y value of negative 3. And then when I put 4 into this equation, my y value came out as positive 3. So now I have 3 ordered pairs. I can plot them on my graph. And let's do that. So x is negative 4, y is negative 9. So here's negative 1, negative 2, negative 3, negative 4, 3, 4, 5, 6, 7, 8, 9. Looks like that point would be right there. Hopefully it's in the right spot. 0, negative 3, so 0, and then 1, 2, there's negative 3 there, and 4 and positive 3. 1, 2, 3, 4, 1, 2, 3. Looks like we are right there. I can take, and would I join these points? Absolutely, because I can take different values of x and substitute them in. So this is continuous data. And if I join the points, it looks something like that. And that graph can go on forever and ever in both directions. And that is graphing an equation when the equation's in a different form from what we're used to seeing. So again, same process. Take your x values, substitute them in. These are just a little bit tougher because I have to use a little bit more algebra, but definitely possible. All right. So the other thing that we have to do in this section are kind of special equations, and these deal with horizontal and vertical lines. I'm just going to get rid of some of this here. So all the equations we've dealt with so far always have two variables. They have an x and a y in them. And if there's an x and a y, or two variables, whatever they are, in an equation, you're always going to get a diagonal line or an oblique line, we've called it before. In horizontal and vertical lines, you're only going to see one variable. And this is just kind of the math lingo for this, x equals a. And if we look at this, what it says here, it says the graph of the equation x equals a, where a is a constant, so a just being a number, any number, is always going to be a vertical line. Every point on the graph has an x coordinate of a. So if we take an actual example, and let's say that this point is 3. So this would be x equals 3. So whenever we have an equation with one variable, and that variable is an x, and x equals a number, it's always going to be a vertical line, and it's going to cross the x-axis at this point, x equals 3. So that's the equation of a vertical line. Now, if you think about, if I just made up points on this line, and let's just say I had all these points on here, and I made a table of values for this line, so if I have an x and a y, and so this point right here on the x-axis, that would be 3, 0, because I go over 3 and up or down 0, so I'd have 3 and 0. This point here, let's say that we're going up by 1s every time. This would be 3 and 1. This point here would be 3 and 2. This one would be 3 and 3. And so what you can see is your x value is always 3. So x is equal to 3. So it's kind of a special equation. One variable involved and a constant. Whatever that constant is, that is where that vertical line, if it's x equals, is crossing the x-axis. So that is what the equation of a vertical line would look like. If I had something like x equals -2, and that was my equation that would be given to me, that means that this is going to be a vertical line crossing the x-axis at -2. So it would be going here, and this would be my -2 right there. So x equals, and just a number, always a vertical line. Similarly, what we have is y equals. And in this case, the graph of the equation y equals a, again, where a is a number, is a horizontal line. Every point on the graph has a y coordinate of whatever that is. So if I said this was, let's say this is crossing here at 2, the equation of this line would be y equals 2. And if I look at every point on this line, if I was to fill in a table of values, and whoa, here's x, here's y. So let's say my x value here's 1, and that's 2. This goes over 2 and up 2. This one goes over 3 and up 2. And this one goes over 4 and up 2. You'll notice that every y value is 2. So any horizontal line will always be in the form of y equals and a number. If, for example, I had a line that went through here, and this was 5, this equation would be y equals 5. So those are two kind of special equations. Anything that's x equals and a number will always be vertical. Anything that's y equals and a number will always be horizontal. And those are just two things that you need to remember. So one variable, these equations both only have one variable, not two. So it's either going to be a vertical line in x equals, horizontal line in y equals. And that's horizontal and vertical lines. That's as tough as it gets. You just have to remember x equals is vertical, y equals is horizontal. So if we look at these next couple of examples here, what we're asked to do is graph each of these equations and describe the graph. So you'll notice right off the bat, if I look at these equations, first one variable. Second one, there's only one variable. Third one, there's only one variable. So I know these are all either going to be horizontal and vertical. Okay, there's not an x and a y, just either or. Okay, so this one is x equals -4. Now I know that any x equals equation will always be a vertical line, and in this case, it's going to cross the x-axis at -4. So if I wanted to graph this line, I would go to -4, 1, 2, 3, 4. Here's -4 here, and I know it's a vertical line. And whoa, actually, I'm going to do that differently so you can actually see it. So here's my -4. Where's it at? And we've got 1, 2, 3, 4, and that was going to be a vertical line crossing the x-axis at -4. So if you're asked to graph that one, that's as tough as it gets. There's -4, that graph goes on and on forever and ever in both directions. That is x is equal to -4. Describing it, it's a vertical line that crosses the x-axis at -4. This one here, y plus 2 equals 0. Again, I know that this only has one variable, and so it's going to be horizontal or vertical. It's the y value, so I know it's going to be a horizontal line. Well, how do I rearrange this? Well, let's just make it y equals. Algebraically, again, I just go -2, -2, and I have y is equal to -2. So the equation of this line is y equals -2. What that looks like, if I have -1, -2, there's my -2 on my y-axis. Take my line and I'm going to graph it. And that is an example of y equals -2. Whoops. So there is y equals -2. Horizontal line crossing the y-axis at -2. This one here, 2x equals 5. I know there's only one variable. It is an x, so this is going to be a vertical line. I just need to put it in the form of x equals. So algebraically, again, all I do is divide both sides by 2, and I end up with x is equal 5 divided by 2 is 2.5 or 2.5. So I know this is going to be a vertical line crossing the x-axis at 2.5. So there's 1, 2, 2.5 is about there. And if I graph it, let's take this, and looks like it'd be about right about there. So vertical line at 2.5. And again, this graph goes on and on forever and ever in both directions. So that's horizontal and vertical lines, what the equations look like, and what the graphs of each of those types of lines look like. So that again is just other forms of equations of a linear relation. Again, this one has two variables in it, and you can see that we have an oblique or diagonal line. These ones here have one variable. You can see we're going to have vertical or horizontal lines. And that is topic 6.3, other forms of equations for linear relations. Again, in this one, we'll also have a handout attached for you for your assignment. So good luck. Again, if you have any questions ever, please contact us and we'd be happy to help you. Have a good day.